chapter, we talk about series. First of all, we have to understand what is binomial theorem. Binomial theorem may be used for expansions. Binomial theorem provides a way to expand expressions in the form of a plus b to the power of n. It follows the formula of NCR, a to the power of n minus r, or b to the power of r. As you can see as a summary over here, the NCR is the binomial coefficients, is evaluated using this formula, but it's more often evaluated using your calculator NCR. For an example, if you would like to expand 1 plus 2x to the power of 4, all you have to do is to apply the formula 4c0, 1 to the power of 4, 2x to the power of 0, 4c1, 1 to the power of 3, 2x to the power of 1. So it goes in the order of, the first term is in a descending order, and the second term in the binomial expansion is in the ascending order. And it continues. 4c2, 1 to the power of 2, 2x to the power of 2, 4c3, 1 to the power of 1, 2x to the power of 3, as well as 4c4, 1 to the power of 0, 2x to the power of 4. Okay, there is a missing 2x to the power of 4. And so we would like to expand this, and if you do it correctly using your calculator, you will then get these terms correctly. Sometimes you will also be asked to figure out the general term or a specific term of a binomial expansion. For example, in this particular example, they would like you to find a term independent of x. It means x to the power of 0. In the expansion of 3x plus 1 over x to the power of 8. Is it possible to get one of those? Yes, because our first term has a positive index. Our second term in the binomial expansion has a negative index. So there could be a chance that if you add up these two indexes, then they get to the power of 0. And we would like to figure out when will that happen. So as you can see, we would like to assume that NCR, and in this case n equals to 8, the first term to the power of n minus r, second term to the power of r. We would like to have the power to be power of 0. So x to the power of 8 minus r multiply x negative 1 r, and you would like to have this to be x to the power of 0 so that you achieve the independent term. So basically you're talking about 8 minus 2r equals to 0, or r equals to 4, as you can see over here. When r equals to 4, if you substitute it, it is at the fifth term, but however, according to the formula, is 8c4, 3x to the power of 4, 1 over x to the power of 4. So making the necessary expansions, you will then get 1134. So this is the coefficient of when the independent term happens. Another type of series we would like to talk about includes arithmetic progression and geometric progressions. Arithmetic progressions is when there is a common difference. A quick example is 1, 3, 5, 7. Everything is adding by a 2. It can also be in a descending order, 7, 5, 3, 1, and the list continues. Everything, the next term may be evaluated by simply minus 2. Geometric progressions, on the other hand, is when there is a common ratio. It can be a multiple of 2, it can be everything divided by 2 for you to get the next term. When we look at the first example, 2, 5, 8, 11, we notice that this is an arithmetic progression because we notice that 5 minus 2 equals to 3. This is the common difference. And it is correct for the next continued terms. If you keep on at 3, you will then get the next term. On the other hand, for the second series, you realize that 6 divided by 3 has a common ratio of 2, and that is correct. If you multiply the previous term by 2, you will then get the next term. So that is how we identified the difference between arithmetic progressions and geometric progressions. This is the formula to figure out the nth term of arithmetic progressions, where you have Tn equals to a plus n minus 1 times d. You can also find the summation of the first n term. What does it mean? When you have 1, 3, 5, 7, 9, you can find the summation of these 5 terms. So we call that S5. A formula is given. It can also be expressed in another form, where you have n over 2a plus l, where l stands for the last term. Similarly, you can also figure out the Tn term for geometry progressions, and formula is as such. You can also figure it out for summation of the first n terms of geometry progressions. A quick example, if you would like to figure out the 10th term of these arithmetic progressions, the first thing you need to do is to identify the formula. Because you would like to figure out the 10th term, so you use the Tn formula, not the summation, because the question does not mention the word summation or any synonym or any related terms. So n equals to 10, a, which is the value of the first term, equals to 3, d, which is the common difference, 7 minus 3, d equals to 4. Substitute T10 equals to a plus n minus 1, which is 9, multiplied by 4, so the answer is 39. Some geometry progressions is convergent. The reason is, if the common ratio is less than 1, then this list will be getting smaller and smaller, such that the next continual terms are going to be insignificant. What do I mean? For example, if you have a list starting from 2, and then the next thing is 10 less smaller than this, so 0.2, 0.002, 0.02, 0.002, up to a certain extent, is going to be so small that it's going to be insignificant, right? Not significant anymore. So when you have such a situation, you will then be able to deduce a summation to infinity. So the summation to infinity formula is as such, and it can be only used when you have absolute values of r smaller than 1. For example, in this particular example on this page, our first term is 5, our second term T2 is 2.5, our common ratio can be found by using 2.5 divided by 5, which is 1 over 2. 1 over 2 is smaller than 1. So we will be able to figure out the summation to infinity, where we will substitute the values of a, 1 minus 1 over 2, and eventually you will then get the values of 10. Here are some practice problems. We are going to share with you how to solve this. 2 plus 3x to the power of 5 using binomial expansions equals to 5c0, 2 to the power of 0, 2 to the power of 5, 3x power of 0, plus 5c1, 2, 4, 3x to the power of 1, plus 5c2, 2 to the power of 3, 3x to the power of 2, plus 5c3, 2 to the power of 2, 3x to the power of 3, 5c4, 2 to the power of 1, 3x to the power of 4, plus 5c5, 2 to the power of 0, 3x to the power of 5. So press the calculator, then you will be able to get the answers. Number 2, Find the independent term, x plus 2 over x power of 6. So we would like to figure out, according to the formula, it goes like 6cr x to the power of 6 minus r, 2 over x to the power of r. In another word, for you to get independent term, x to the power of 0 is what you would like to achieve. Then this is when x, 6 minus r, 6 minus 2r equals to 0, r equals to 3. So it will happen when r equals to 3, or during the fourth term. When r equals to 3, the remaining coefficient of the independent term is going to be 63, 2 to the power of 3. Press the calculator, then you will be able to get the answers. Is this a GP or AP? This is a GP. If this is an AP, then it should have a common difference. 8 minus 4 equals to 4, 16 minus 8 equals to 8. The difference between two consecutive terms are not the same, so it's not AP. Test common ratio. Indeed, it has a common ratio. If you multiply the present terms by 2, you will then be able to get the next term. Calculate the sum of the first 6 terms. So we're evaluating as 6. Our A value is 4, common ratio is 2. So as 6 equals to A, 1 minus Rn, 1 minus R equals to A, 1 minus 2 to the power of 6, 1 minus 2. Evaluate it, then you will be able to get the answers. Find the first 8 terms. This is an AP according to the questions. So A equals to 2, D equals to 5 minus 2, which is 3. And in this case, we would like to figure out summation of the first 8 terms, x8. So it's equivalent to n over 2, 2a plus n minus 1 times d. So again, press the calculator carefully, you'll then be able to get the answers. Last but not least, the question also changes slightly. Currently, we would like to figure out summation to infinity. So for you to apply this formula, you must have common ratio to be in between 1 and negative 1. Indeed, our common ratio of half shows that it is smaller than 1. And our first term is 4. So as infinity equals to 4, 1 minus half, then the answer is going to be 8. Please do the extra exercise reference materials. Thank you very much for listening. Bye bye.